Perhaps one of Britain's most iconic structures, the Crystal Palace in London, embodied the opulence and grandiose design of the Victorian era, originally being erected to house the Great Exhibition, with its size and scale reflecting the nation's position on the world stage. Sadly, once its magnificent place in Victorian history had passed, this huge structure began to fall slowly into obscurity, before meeting a tragic end as a result of fire, embodying a possible metaphor as to the wider decline of the globe-spanning empire it once stood to represent. Contrary to popular belief, the Crystal Palace was not a single structure, but in fact two buildings located within the London area, the first being constructed in Hyde Park during 1851 to house the Great Exhibition of that year, while the second was erected in 1854 and situated on Penge Common at the top of Sydenham Hill in South London. The concept behind the Great Exhibition was brought about in January 1850 and considered the display of cultural items and aspects from many of the nations that fell under the rule of the British Empire, the project being first proposed by the Great Exhibition Commission and would be funded by public subscription. This was followed by the establishment of an executive building committee to oversee the design and construction of the exhibition building, with this committee comprising the greatest architectural and engineering minds of the era, including Isambard Kingdom Brunel, Robert Stevenson, Charles Barry, Thomas Leverton Donaldson, and the Earl of Ellesmere, while being chaired by civil engineer William Cubitt. On March 15, 1850, the Commission issued invites to the various architects and designers to submit their proposals, based on a very strict set of specifications, these being that the building had to be temporary, simple, as cheap as possible, and economical to construct within the short time remaining before the exhibition opened, which had already been scheduled for May 1, 1851. Within 3 weeks, the committee had received some 245 entries, including 38 international submissions from Australia, the Netherlands, Belgium, Hanover, Switzerland, Brunswick, Hamburg and France, with 2 designs, both in iron and glass, being singled out for praise, one by Richard Turner, co-designer of the Palm House at Kew, and the other by French architect Hector Horot. Despite their merits, all of the submitted proposals would ultimately be rejected by the committee, with Turner taking this rejection poorly and demanded compensation for his efforts in excess of £300,000, though regardless, the committee eventually settled on a standby design of its own, which would comprise a brick building developed by Thomas Leverton Donaldson, which would feature a sheet iron dome designed by Brunel. This proposal, though, was widely criticised and ridiculed when it was first published in the newspapers, while adding to the committee's woes was the fact that the site for the exhibition had still not been confirmed, with the preferred location being in Hyde Park, adjacent to Prince's Gate near Kensington Road, though other potential sites included Wormwood Scrubs, Battersea Park, the Isle of Dogs, Victoria Park and Regent's Park. Hope came, though, in the form of Joseph Paxton, who had garnered an interest in the project and worked with Commission member Henry Cole to submit his own design, Paxton being known for his celebrated career as the head gardener for William Cavendish, 6th Duke of Devonshire at Chatsworth House, and by 1850 he had become a preeminent figure in British horticulture, his works including the pioneering public gardens at Birkenhead Park, which directly influenced the design of Central Park in New York. The inspiration for Paxton's submission came from his experience working at Chatsworth, where he had experimented extensively with glasshouse construction, developing many novel techniques for modular construction, using combinations of standard-sized sheets of glass, laminated wood, and prefabricated cast iron. The Great Stove or Conservatory at Chatsworth, built in 1836, was the first major application of Paxton's ridge and furrow roof design, and was at the time the largest glass building in the world, covering approximately 28,000 square feet, while in 1846, taking advantage of the availability of the new cast plate glass, Paxton further developed his techniques with the Chatsworth Lily House, which featured a flat roof version of the ridge and furrow glazing and a curtain wall system that allowed the hanging of vertical bays of glass from the iron cantilevered beams. Following a meeting with Henry Cole on June 9, 1850, Paxton was ready to begin work on developing the new exhibition palace, heading straight to Hyde Park and walking the proposed outline of the structure, followed 2 days later, during his attendance at a board meeting of the Midland Railway, by Paxton making his original concept drawing as doodled onto a sheet of pink blotting paper. Within 2 weeks, the detailed plans, calculations and costings were ready to submit, with the overall budget of his design being remarkably low at only £85,800, which, by comparison, was only 2.5 times more than the Great Stove at Chatsworth, but only 28% of the estimated cost of Turner's design. The building promised a footprint of over 770,000 square feet and would cover roughly 25 times the ground area of its progenitor, the committee being impressed by the low bid for the construction contract submitted by the engineering firm Fox Henderson & Co., and thus accepted the scheme in July 1850. As such, Paxton was able to design and build the largest glass structure yet created from scratch in less than a year and complete it on schedule and on budget, while also being able to alter the design shortly before building began by adding a high barrel-vaulted transept across the centre of the building at 90 degrees to the main gallery, under which he was able to safely enclose several large elm trees that would otherwise have needed to be felled. The shape and size of the whole building was directly based around the size of the panes of glass made by the supplier, the Chance Brothers of Smethwick, these being the largest available at the time, measuring 10 inches wide by 49 inches long. While due to the entire building being scaled around these dimensions, it meant that nearly the whole outer surface could be glazed using millions of identical panes, thereby drastically reducing both their production cost and the time needed to install them. The original Hyde Park building was essentially a vast, flat-roofed rectangular hall with a huge open gallery running along the main axis, with wings extending down either side, with the main exhibition space being 2 stories high, with the upper floor stepped in from the boundary. Most of the building had a flat-profile roof, except for the central transept, which was covered by a 72-foot-wide barrel-vaulted roof that stood 168 feet high at the top of the arch, with both the flat-profile sections and the arched transept roof being constructed using the key element of Paxton's design, this being his patented ridge and furrow roofing system that had first seen use at Chatsworth. The basic roofing unit, in essence, took the form of a long triangular prism, which made it both extremely light and very strong, and meant it could be built with the minimum amount of materials, these being horizontally supported by a grid of cast-iron beams, which were held up on slim cast-iron pillars. The resulting cube, with a floor area of 24 foot by 24 foot, formed the basic structural module of the building, and by multiplying these modules into a grid, the structure could potentially be extended indefinitely, while in its original form, the ground level of the Crystal Palace, in plan, measured 1,848 feet by 456 feet, equating to a grid 77 modules long and 19 modules wide. Because normal cast glass was brittle and had a low tensile strength, there was a risk that the weight of any excess water buildup on the roof might have caused panes to shatter, showering shards of glass onto the patrons, ruining the valuable exhibits beneath, and weakening the structure. However, Paxton's ridge and furrow roof was designed to shed water very efficiently, with rain running off the angled glass roof panes into U-shaped cast-iron channels which ran the length of each roof section at the bottom of the furrow, this design feature also helping during construction, and was used as rails to support and guide the trolleys on which the glaziers sat as they installed the roofing. Once completed, the channels acted both as the joist that supported the roof sections and as guttering, which is now patented as the Paxton gutter, these gutters conducting rainwater to the ends of each furrow, where they emptied into the larger main gutters set at right angles to the smaller gutters along the top of the main horizontal roof bearers. These main gutters drained at either end into the cast-iron pillars, which also served the dual function of providing a concealed downpipe that carried the stormwater into the drains beneath the building, while to maintain a comfortable temperature inside such a large glass building was another major challenge, largely due to the fact the exhibition took place decades before the introduction of mains electricity and air conditioning. These problems were solved through an early ventilation system designed by Paxton, with each of the modules that formed the outer walls of the building being fitted with a prefabricated set of louvres that could be opened and closed using a gear mechanism, allowing hot stale air to escape, while heat dissipation was also provided through the floor, consisting of boards 8.7 inches wide which were spaced about 0.39 inches apart. Together with the louvres, this formed an effective passive air conditioning system due to the pressure differential, with hot air escaping the louvres, able to draw cooler air up through the gaps in the floor at a near constant rate, this providing not only a primitive form of air conditioning, but also meant that the gaps between the boards could act as a grating that allowed dust and small pieces of refuse to fall or be swept through them onto the ground beneath, where they would be collected daily by a team of cleaning boys. Thanks to the considerable economies of scale, Paxton was able to manufacture and assemble parts of the building with exceeding speed and cost-effectiveness, with each module being identical, fully prefabricated, self-supporting, and easily erected, thereby meaning they could be mass-produced in significant quantities and, in many cases, parts served multiple functions, further reducing both the number of parts needed and their overall cost. Thanks to the simplicity of Paxton's design and the combined efficiency of the building contractor and their suppliers, the entire structure was assembled at an extraordinary pace, with the team of 80 glaziers being able to fix more than 18,000 panes of sheet glass in a week, and the building was completed and ready to receive exhibits in just 5 months. For his achievement, Paxton received worldwide acclaim and was knighted by Queen Victoria in recognition of the mighty structure he had created, the Great Exhibition being declared open by the Queen on May 1, 1851, becoming the first World's Fair exhibition for culture and industry, which would later be emulated by the legendary World's Fair events in the United States during the 20th century. In total, there were some 100,000 objects provided by 15,000 contributors over more than 10 miles of exhibition space, with half of the display space being occupied by exhibits from both within the UK and from the British Empire, while France followed as the largest foreign contributor, the exhibits being grouped into 4 main categories: raw materials, machinery, manufacturers, and fine arts, while in the main transept adjacent to the preserved elm trees was the 27-foot-tall crystal fountain. Initially, prices were set to £1, but these were reduced to 5 shillings for the next 3 weeks in order to allow the newly emerging middle classes to visit, while prior to this, only the aristocratic classes were allowed into the venue, the working classes also being allowed into the exhibition from May 26th, following the reduction of prices to 1 shilling, although the price was 2 shillings and 6pence on Fridays and 5 shillings on Saturdays. In all, the exhibition accounted for over 6 million admissions at the toll gates, although an unknown proportion of these were repeat or returning visitors, with the surplus profits from the Great Exhibition, amounting to £186,000, being used to found the Victoria and Albert Museum, the Science Museum, and the Natural History Museum in South Kensington. Aside from the many pioneering structural elements behind the Crystal Palace, there were also many functional inclusions that were world firsts, with the Crystal Palace having the first major installation of public toilets, retiring rooms which were fitted with sanitary engineer George Jennings' monkey closet flushing lavatory, with 827,280 visitors paying 1 penny to use them during the course of the exhibition, which gave rise to the term spend a penny. Eventually, the exhibition closed on October 11, 1851, rendering the gigantic Crystal Palace now surplus to requirement, though while Parliament considered simply dismantling the building, a consortium of 8 businessmen, including Samuel Lang and Leo Schulster, who were both board members of the London, Brighton and South Coast Railway, formed a suitable holding company and proposed that the edifice be erected on a property named Penge Place that had been excised from Penge Common at the top of Sydenham Hill. While common belief is that the Hyde Park Crystal Palace was taken apart and shipped en masse to Sydenham Hill, the second Crystal Palace was in fact an entirely different structure. The new building, while incorporating most of the constructional parts of the Hyde Park building, being so completely different in form as to be properly considered a quite different structure, with a Beaux-Arts form in glass and metal. The main gallery was redesigned and covered with a new barrel-vaulted roof, the central transept was greatly enlarged and made even higher, and 2 new transepts were added at either end of the main gallery, the new palace being built within just 2 years, and on June 10, 1854, Queen Victoria again performed an opening ceremony in the presence of 40,000 guests. As part of its contract with the London, Brighton and South Coast Railway, 2 train stations were opened to serve the permanent exhibition, the first station being Crystal Palace Low Level, which was opened in 1854 and located just off Annerley Road, while the second station was Crystal Palace High Level, which was developed by the London Chatham and Dover Railway in 1865 and designed in a grand style by Edward Barry. Surrounding the rebuilt Crystal Palace, experts such as Matthew Digby Wyatt and Owen Jones were hired to create a series of courts that provided a narrative of the history of fine art, among these being Augustus Pugin's medieval court from the Great Exhibition, as well as courts illustrating Egyptian, Alhambran, Roman, Renaissance, Pompeian, and Grecian art among others, though in 1866 the Egyptian court burnt down for unknown reasons and due to a lack of adequate insurance was never rebuilt. Due to Joseph Paxton's love of horticulture, the greatest possible emphasis was placed on the development of the gardens surrounding the rebuilt palace, including water features such as fountains and cascades, though this presented the issue of water supply, with thousands of gallons required at a place miles from the nearest river. The solution, therefore, was the creation of 2 water towers, but these promptly collapsed when the weight of the water inside caused them to buckle, with Isambard Kingdom Brunel being consulted, who would eventually develop plans for 2 replacement water towers at the north and south ends of the main building, each supporting a tremendous load of water, which was gathered from 3 reservoirs at either end and in the middle of the park. Elsewhere, Edward Milner designed the Italian gardens and fountains, the Great Maze, and the English landscape garden, while Raphael Monti was hired to design and build much of the external statuary around the fountain basins and the urns, tazes, and vases, with sculptor Benjamin Waterhouse Hawkins also being commissioned to make 33 life-size models of the then newly discovered dinosaurs and other extinct animals. In the central transept was the 4,000-piece grand orchestra built around the 4,500-pipe great organ, as well as a concert room with over 4,000 seats that hosted successful Handel festivals for many years, the Crystal Palace, as the centre of British and by extension world culture, being famed for a number of pioneering events during its life, including the world's first aeronautical exhibition in 1868 and the world's first cat show in 1871. Other events held at the palace included dog shows, pigeon shows, honey shows, and flower shows, as well as the first national motor show, while in 1909, Robert Baden-Powell first noticed the interest of girls in scouting while attending a Boy Scout meeting at the Crystal Palace, leading to the creation of the Girl Guides and later Girl Scouts, this being followed in 1911 by the Festival of Empire, which was held at the Crystal Palace to mark the coronation of King George V and Queen Mary. During World War I, the palace was requisitioned by the Royal Navy for use as a land-based training establishment called HMS Victory 6, informally known as HMS Crystal Palace, and throughout its time as a naval base, more than 125,000 men from the Royal Naval Division, Royal Naval Volunteer Reserve, and Royal Naval Air Service would train at this location. Towards the end of the war, the Crystal Palace would reopen to the public as the site of the first Imperial War Museum, forming part of a wider initiative called the Imperial War Museum and Great Victory Exhibition Crystal Palace, this initiative being superseded by the movement of the Imperial War Museum to South Kensington, and then in the 1930s to its present site at Geraldine Mary Harmsworth Park. However, in the years following the end of hostilities, it became clear that the Crystal Palace was facing significant decline due to its age, as while the original palace had cost £150,000 to build in 1851, equivalent to £16.1 million in 2024, the move to Sydenham had cost £1.3 million, or £129 million in modern currency, a debt that was never fully repaid, due in part to depressed admission fees for Sunday visitors. Upkeep of the gigantic structure was an uphill battle wrought with difficulty due to the sheer cost of maintaining such an engineering feat, and by 1911, the deterioration of the Crystal Palace was such that, despite the building being cleaned up for the Festival of Empire, the rot was quick to reaffirm itself, and during the same year the palace was declared bankrupt as maintenance costs continued to spiral, with only the purchase of the building by the Earl of Plymouth in 1914 saving it from closure. In the 1920s, a board of trustees was established under the guidance of manager Sir Henry Buckland, as fueled by both his love of the Crystal Palace and his desire to run a tight ship, thus beginning a long, arduous restoration project to fix the many problems plaguing the deteriorating structure. The restoration not only brought visitors back, but also meant that the palace started to make a small profit once more, with the surplus income being used by Buckland and his staff to improve the fountains and gardens, including the Thursday evening displays of fireworks by Brock's. Perhaps the last notable use of the Crystal Palace was by John Logie Baird, who took up residence in the South Tower and parts of the palace's lower level in order to test his mechanical television, Baird having become the pioneer of television and used the South Tower to test transmissions before utilising the BBC's transmitters at Alexandra Palace in North London for his 6-month public trial, commencing from November 2, 1936. On the night of November 30th of the same year, though, the Crystal Palace met a sudden demise when a fire broke out and quickly ripped through the structure, causing its near-total collapse, the blaze having started in a small office, with firefighting efforts initially undertaken by 2 employees, while Buckland himself was the first to inform the Penge Fire Brigade of the blaze, as he and his daughter Crystal, named after the structure, happened to be walking their dog past the palace when he noticed a faint glow inside. Fueled by a high wind and dry old timber flooring, as well as an abundance of flammable material, the palace was soon an inferno, the glow of its flames visible across 8 counties, and despite the gallant efforts of 89 fire engines and over 400 firemen, the scale of the blaze could not be extinguished with the rudimentary equipment of the day. In the end, nothing could be done to save the building, and dawn soon revealed the scale of the destruction, with the entire palace reduced to a pile of melted and contorted steel that smouldered for days, the psychological impact of the building's destruction being further emphasized by the scandal surrounding the abdication of King Edward VIII. Also lost in the fire was the work of John Logie Baird, a majority of whom's research had been destroyed during the blaze, his mechanical television concept being ruined, and the 6-month trial with the BBC curtailed indefinitely, leaving the future of television in the hands of American inventor Philo Farnsworth, who utilized an all-electric system that is the standard of the modern era. While both water towers and the gardens had survived the chaos, the South Tower had been damaged beyond repair and was taken down soon afterwards, while the North Tower remained in situ until 1941, whereupon it was demolished by explosive in order to stop it being used as a landmark for German bombers during the Blitz, though in reality, the Luftwaffe used the Thames as a navigational guide towards London. Also left was the high-level station and branch line, but without a destination to serve anymore, its passenger numbers plummeted, forcing its eventual closure in 1954, with the station building itself standing in place until 1961 when it was finally demolished. No attempt was made to rebuild the Crystal Palace, as with the 1866 fire that had destroyed the Egyptian court, there was no adequate insurance policy to cover the building, and thus any costs in creating a new structure could not be compensated, the former park and site being redeveloped to include the Crystal Palace transmitting station on the former aquarium site in the mid-1950s, which still serves as one of London's main television transmission masts. Prior to its destruction, the park surrounding the Crystal Palace was also a pioneer for motor racing speedways, with 1928 seeing a racing circuit be constructed, initially for motorcycle racing, followed in the 1930s by dedicated car races, the speedway remaining in use until 1972, at which point it was abandoned due to falling patronage, although many sections of the track remain in a disused state, while in 1964, the National Sports Centre was built on the old Crystal Palace football ground. As for the potential to build another Crystal Palace, many plans have been mooted, but none realised, with the presence of multiple exhibition venues in the London area, including the former Millennium Dome and the ExCeL near London City Airport, meaning the demand for such an incredible structure would not make sense on an economic level, and would exist merely for its own sake, as a reminder of a long-demolished Victorian icon. In the end, the Crystal Palace was perhaps the pivotal example of simple but sturdy Victorian engineering, a collection of uncomplicated design aspects brought together to create a gigantic temporary structure that housed one of the finest public exhibits in British history, the building, in both incarnations, being an attraction in and of itself due to its exceptional mixture of size and beauty that was immediately recognisable across the world.